Hi, my name is Jingyi Xie. I'm the first author and presenter for the paper, YouTube Videos as Data, Seeing Daily Challenges for People with Visual Impairments During COVID-19. I completed this work with the help of Na Li, Suyang Li, and John Carroll. COVID-19 pandemic has spread globally and affected a large number of people. Previous studies understood the experience of people with visual impairments during COVID-19 and revealed the challenges in terms of mobility, technology, health, and so on. Regardless of the diverse focuses, previous studies collected and analyzed survey or interview data on online platforms. Thus, little has been observed in people with visual impairments' daily activities due to the suspension of face-to-face fieldwork. Additionally, prior work mainly focused on people with visual impairments challenges during the pandemic and proposed mitigations targeting specific ones, and rarely uncovered the problems causing pandemic-related challenges for people with visual impairments. And a little bit more background about research on the visually impaired community on YouTube. Researchers have analyzed a specific type of video, namely visually impaired people tag videos that were created by visually impaired vloggers only. However, usability obstacles such as video editing issues reduce the accessibility of this channel to people with visual impairments as primary authors. To alleviate this problem, we use a different data source, existing YouTube videos. Videos directly depict people with visual impairments in challenging situations, rather than engaging them to talk about the situations in controlled interviews or surveys. Additionally, we took a broader look at the videos where there were authors and also videos where there were active participants. For example, videos published by the news media community. Second, by observing grocery shopping and airport navigation in publicly available YouTube videos, we demonstrated the use of videos that record visually impaired people's daily life in lieu of the ethnography approach restricted by the COVID-19 pandemic. Third, we uncovered the problems causing pandemic-related challenges and highlighted the need of providing people with visual impairments with more accessible and inclusive prevention guidelines, as this study indicates that accessibility can be easily ignored under unforeseen situations, like the COVID-19 pandemic. We selected a collection of free, publicly visible YouTube videos that were published before January 15, 2022. First, we defined a set of search queries by combining health condition-related search terms such as blind, visual impairments, visually impaired, with situation-related search terms such as coronavirus, COVID-19, COVID, quarantine, lockdown, and self-isolation. We browsed top 115 search results returned by YouTube for each combination, and manually checked the title of each result and recorded any results containing the search queries or their synonyms. For example, vision impairment returned under the search for visual impairments. The initial collection included 181 videos. Then we excluded 105 videos that are not related to or do not involve people with visual impairments by reviewing the themes of videos. These videos record blindfold activities during the pandemic, such as blind date and blind taste, or songs with the word blind in titles, such as We're So Blind. This process narrowed down the number of videos from 181 to 76. We watched those 76 videos separately. Then we excluded 6 videos with English titles but not recorded in English or not translated into English with subtitles. We further removed 19 videos that involve visually impaired people but did not reveal any challenges they encountered during the pandemic. Finally, the collection included 51 videos for further analysis. Among the 51 eligible videos, 24 videos were created and published by the visually impaired community, including daily, travels, and informative vlogs, where 25 people with visual impairments were involved. 27 videos were published by the news media community, including tracking shots, interviews, and dictation of people with visual impairments, where 32 were involved. Throughout the following sections, we use PV star to denote the videos published by people with visual impairments and use P star to represent the visually impaired people depicted in them. Similarly, NV star and N star to denote those from news media community. We adopted video data analysis to transcribe both video and audio data and use a bottom-up approach to perform a qualitative data analysis. We analyzed both narratives and visual content and ended up with 4 high-level issues. 1. Social distancing protocols and challenges. 2. Masking and challenges. 3. Challenges in use of touch for tactile information. 4. Challenges in digital accessibility. I cannot go into all of them in this presentation, but I will look more closely at the first 2 themes. For the full themes and findings, please see the paper. One cause for social distancing challenge is a conflict with visually impaired people's depth perception strategies. 2 people with visual impairments depicted in the videos use the lens of a wide can for reference to get the awareness of the social distance. N10 said, quote, "Social distancing is difficult, like I know my can, for instance, is 1.2 meters, so that helps. So I know there's got to be further than that, but when you can't see, you just haven't got the same concept of that distance, so I was really worried about it." We observed that P12 helps his guide dog holds a white can with one hand and pulls his suit kit with the other when waiting in line for check-in. He proceeds slowly, swinging the white can, then stops until the white can taps the traveler's foot to recognize the line and follow social distancing. Another reason is that guide dogs don't understand social distancing, so they will swerve in between people closely and they are not gonna know that. This statement was supported by the observations of videos from the visually impaired community. The guide dog swerved to ensure people move through the space safely without running into obstacles. However, the guide dog failed to adjust and maintain distance from pedestrians, and sometimes was too close to the former pedestrian when waiting in line, forcing P4 to break the social distancing. There are also other 2 causes for social distancing challenges: narrow and crowded spaces and inaccessible signs of one-way system. Please see our paper for more details. The second challenge is masking, which was rarely declared by people with visual impairments in recorded interviews or informative vlogs. However, it was recurrent in observations of P4's daily and travel vlogs, suggesting that people with visual impairments may not be conscious of this frequent, potentially dangerous situation. Without any non-visual feedback on the status of people's masking wearing, P4 ran into people without masks who walked quietly on the tile pathway in the store, and she didn't notice that an airport assistant and a waitress took off the mask and put it on the chin during a conversation. We articulate how these challenges can be mitigated with technologies. Pedestrian detection and collision avoidance systems have the potential to mitigate the challenge of social distancing in crowded spaces. Proved effective in previous studies, if given appropriate information about visually impaired people's presence, sighted pedestrians can quickly clear a path for people with visual impairments who are walking. Identifying and social distancing from people who wear masks improperly is another challenge for people with visual impairments. Building upon face recognition and object detection, algorithms can be developed to detect whether people are wearing masks properly or not. Despite the promising applications of computer vision, these camera-based solutions would entail privacy concerns to bystanders. Due to the narrow view of camera, people with visual impairments need to scan the appropriate areas at the correct angle, meaning that the camera will be pointed to bystanders' face for mask detection. Although some side effects might emerge from the adoption of computer vision technologies, the great advantages do merit future investigation. We need to be cautious about the side effects that computer vision techniques may bring and try to protect bystanders' privacy to the greatest extent possible. In this work, we utilized publicly available YouTube videos to identify 4 types of challenges encountered by the visually impaired community during the COVID-19. We reviewed the causes for these challenges and discussed the potential applications of technologies to mitigate them. And that's it. We thank Ji-Young Kim for her assistance in data analysis. Thank you again to NIH and our reviewers. For more details, please read our paper. And thank you all so much for listening.